What is velocity of sound in air at 20 degrees Celsius? Theory: velocity of sound is directly proportional to square root of temperature, that is V directly proportional to root T. At 0 degrees Celsius, that is at 273 Kelvin, let V0 be the velocity. V0 is proportional to root of 273. At T degrees Celsius, on converting T degrees Celsius to Kelvin, we get 273 plus T degrees Celsius. So this is the temperature in Kelvin scale. Now velocity V is directly proportional to root of 273 plus T degrees Celsius. On dividing the two equation, V by V0 equal to root of 273 plus T by 273. On dividing, we get 1 plus T by 273. Instead of square root, we can write raised to minus half, and opening the brackets, we get 1 plus T by 2 into 273. That is 1 plus T by 2 into 273 is 546. Now taking V0 to the right hand side, V is equal to V0 into 1 plus T by 546. V0 is 330 into 1 plus T by 546. On opening the bracket, we get 330 plus T into 330 by 546. That is 330 plus. On dividing, we get 0.6. So V is equal to 330 plus 0.6 T. This is the velocity at T degree Celsius. Now using the equation, we can solve. V equal to V0 plus 0.6 into T degree Celsius. V0 is 330 and T is 20 degree. On substituting in this equation, instead of V0 330, instead of T 20, we get 330 plus 0.6 into 20, that is 330 plus 12 equal to 342 meter per second. Find the temperature at which velocity of sound in air become double the velocity at 0 degrees Celsius. Given V0 is 330 meter per second. Also, the new velocity V equal to 2 times V0. Velocity of sound is directly proportional to square root of temperature. That is V directly proportional to square root of temperature. Let T be the temperature at which velocity of sound become double. At 0 degrees Celsius, that is at 273 Kelvin, we can write the velocity V0, that is the velocity at 0 degrees Celsius or at 273 Kelvin, directly proportional to root of temperature, that is 273. At the new temperature T Kelvin, let V be the velocity. V is proportional to root T. On dividing second equation by first equation, V by V0 equal to root of T by 273. Instead of V, we can write 2V0. So 2V0 by V0 equal to root of T by 273. We can cancel V0 from the numerator and denominator. So 2 is equal to root of T by 273. On squaring both sides, we get 4 equal to T by 273. So T equal to 273 into 4, that is 1092 Kelvin. 1092 Kelvin is equal to 273 plus T degree Celsius, that is the temperature in Celsius scale. Now T equal to 1092 minus 273, that is 819 degree Celsius. So this is the temperature at which the velocity becomes double the velocity at 0 degree Celsius.